So here we've got a ball thrown vertically upwards at a velocity of 20 meters per second. So it's going vertically upwards. So you can see, actually I'll just do this now. So when you get to that second one, it's why are we taking the positive square root and not the negative square root? Because we're saying that the ball is thrown vertically upwards. So while it's rising, we're saying this is positive v. So v is positive in the upwards direction. So the acceleration is going to be due to gravity, and it tells us to use 10 for gravity. So the acceleration against it, so heading downwards, so negative, is 10. And we're interested in the v squared x equation, so we're going to use d by dx of half v squared. So you know we're going to get half v squared d by dx, so this will be minus 10, integrate with respect to x. And what do we know at the beginning? We do know that at the beginning velocity is 20. So let's make this 20. Velocity is 20 when we start. So let's say x equals 0. So our c is going to be half of 20 squared. 20 squared is 400. Half of that is 200. So our equation, our c is going to be 200. So our v squared, if I multiply everything by 2, I'm going to put the 200 first, which becomes 400 minus 20x. So there's our v squared equation, which gives us our v equation of square root 400 minus 20x. We want to integrate to find the displacement time function. All right, so it tells us again what to do. It says to integrate to find displacement time. So dx to t, remember v is dx to t, so let's go for dx to t, which gives us displacement and time. I'm going to put a root 20 out the front, so I'm factorizing by root 20, and that leaves me with a 20 minus x to the half. All right, so t, so in order to get to t, we need to flip everything upside down. So I've got a 1 on root 20 here, and I'm integrating, so the 20 minus x is not to the power of half, but to the power of minus half, because I flipped it. All right, so you can see that we add 1 to the power, we're going to get a half and divide by a half. So it's going to, and then also this is a negative here, so actually we need a negative. I could put that negative there and negative there now. All right, so we've got negative 1 on root 20. We're going to divide by a half, so this is going to become a 2. We've still got 20 minus x, but now it's the power of a half, and we've got plus c. All right, so we know initially we're starting off at x equals 0. So if we use that, if we make x equals 0, so I'll rub this out so we can see. So initially, x equals 0. So putting that in, I'm going to get 0 equals minus 2 on root 20 times, now 20 minus 0 to the half, so root 20 plus c. So you can see that c is going to be 2. So let's put that in. So I've got t is minus 2 on root 20. I've got 20 minus x to the power of a half, and I'm going to have plus 2. So we need to find how long it takes the ball to reach its greatest height. And we know it reaches its greatest height because we did that one. Did we actually do it? No, I can't remember. I think I missed it. All right, so let's quickly find its greatest height. So we know its greatest height. We did get, sorry about that. Our equation v squared is 400 minus 20x. We know the greatest height occurs when v equals 0. So if I make it equal 0, then 400 is equal to 20x. So x has to be 20 times 20, so 20 meters. So the greatest height is 20 meters. So now that was part of part A that I missed. So now I can put it back in for time. So when x equals 20, obviously this bit cancels, so I just get 2. So at 2 seconds, it takes 2 seconds to reach its greatest height, and then obviously it will fall down.